All right, here we go. Fender Deluxe Reverb on the bench. This is a reissue, probably from late 90s, early 2000s. Customer said they've had it for about 20 years, so that sounds about right, but we'll take a look at the serial number and all that. Once we get it open, should be easy to tell from the circuit board. They've been using this thing for shows and practice, and had it make a funny noise, then pop, and no power. So I suspect this could be as easy as catastrophic failure of one of the power tubes, took out a screen resistor, and then blew the fuse. But we'll open it up, take a look. Okay, so the fuse was blown. It was the proper 2 amp slope low fuse in there. Replace the fuse, put it on the current limiter. It can be fun when you have a failed tube, and if it's only the tube, when you're on the current limiter, you can sometimes see the tube like actually throwing electrons and shorting out, which can be a little entertaining. I was hoping that was going to be the case this time, but it doesn't look like that's what's going on. This tube does seem like it's running a little colder than the other, but they're both lighting up, so heaters are good at the very least. And it is not blowing a fuse anymore on the current limiter. And we have signal getting through from the reverb, so you can hear there. Nothing major's cutting out, so we're going to open it up and see if there's any other issues. Give a closer look. Okay, so we've got that Deluxe Reverb opened up here just to verify there's no major issues going on. I actually have already found that one of our power tubes right here is failed. So this must have taken out the fuse. The other guy's good. I'm going to show you how I test these on my older B&K Dyna Quick tube tester. We also have more Sharpie in the amps, just unnecessary. 120 volts. No kidding. Okay. I don't know why people do this, but I'll quit ranting about that. Couple things to point out though in these amps. So we have our screen resistors here. Somebody's already changed these out for metal oxide style. It's not uncommon for these to blow in these amps when a tube fails short. Metal oxide is always a good way to go for those. They are much more stable at high temps. Fender moved in these 90s and 2000s and on reissues for all of these amps, the Deluxe Reverbs, the Twins, all that stuff, moved these resistors from being on the tube sockets where they get plenty of airflow, can dissipate heat more easily, onto the circuit board. This is one of the failure points in this amp. These can go really easily. There's also some other issues. I've had issues with the coupling caps coming out of the phase inverter, get to the point where the bias is drifting, not to the extent of like a DSL 2000 from the same era, but still bad enough that tubes continuously get taken out unpredictably. That's something to watch out for. The bias circuit also, if I'm really redoing one of these amps, I just go through and change out all of the small signal electrolytic caps. I change out these 2 capacitors for the phase inverter couplings to the output stage. I'll move these screen resistors to the tube sockets and reroute the wiring, and then go from there. I know there's a lot of other people that do a great job on these amps. The Psionic Audio YouTube channel really does a great job with explaining why he does things a certain way for modifications in these. So yeah, we're going to replace these tubes, these power tubes. I shouldn't need anything else. Fortunately, this is just a quick swap, but I am going to show you how to test the tubes on a older style tube tester and what that process looks like for both a good tube and for a bad tube. So we'll go from there, get new tubes in this, check the bias, make sure everything's stable, and then hand this one back to the customer. Okay, so here we are at the DynaQuick Model 500 B&K tube tester. I've already got this guy set up for the tube that we are going to be testing, which is a 6v6. But just to show you, we go to our chart here, go to 6v6, and that tells us the setting for the heater and for the sensitivity here, and then also what socket. So we're going to go socket 8B, which is here, plug in our 6v6, we'll set our heater to 6, so this just determines the heater voltage, set our sensitivity to 75, and then the first test will be a short test to see if it's got a short circuit. If so, this light will come on that we can move through to transconductance, life, and gas. And it takes just a second to heat up, but yeah, we'll check this out. Okay, so we're plugged into socket 6B. I'm going to turn this guy on, and it'll take just a second to come up. We're first going to test the good tube. You can see the tube is starting to light up just a little bit. I haven't used this thing in years until recently. I thought I needed to rebuild it and calibrate, but I actually received this from my brother years ago, and I think he already did all that. So let's see if we... Okay, so a little worn out, potentially, assuming this is calibrated correctly. I did test some known good tubes on this, and they were going within the good range. This is just barely on the tail end, what we would expect, but we can see there's nothing for the gas, nothing for the short circuit. Transconductance, or GM, is in our bottom end of our good range, and same with life. So this is the good tube. Now let's see what happens when we plug in the one that looks like it's probably problematic. Okay, so same socket, same settings. Firing this guy up. And now we don't have a short circuit. But if I go to our GM setting, it's nothing. If we go to our life, no life. Nothing left. Gas. So this one's just showing up with nothing on the board, which means we've got a failed tube. Now we can also test this in the amp with our bias meter to see if there's any current getting pulled. Let's do that. Okay, a little bit of a wiring mess here, but we've basically got our CompuBias hooked up to both these tubes. I've marked the one I suspect is bad with a little painter's tape there. That's going into our probe 1 here. Now, we're still going to plug into our current limiter just in case there was a short circuit in this tube. I already fired it up on the current limiter earlier, and I didn't see a short circuit. So I think this tube has just failed open in some way, which makes this a safer test for verifying that that is specifically the tube that has failed. But we're going to turn this amp on with the CompuBias setup on the current limiter, hooked up to the load box for our speaker output, and just see if we have any actual current being drawn by that tube. Okay. So we should be coming up. Let's see if we can get this out of the light. Okay, our plate voltage is starting to come up. I've got my hand on the current limiter just in case things get out of control. And what we're looking for is that there's no current drawn. Yep, so probe 1 is not pulling any current. Probe 2 is. It's lower than it should be because we're hooked up to the current limiter. But we can see probe 1 has nothing. So that tube is not pulling current. Just as the tube tester said when we hooked up to that, that tube has failed open. Okay, so good confirmation. 2 ways to do this. If this was a failed short tube, we would get so much current being pulled through it that it would cause issues. But this is a unique situation where we can do a test with our bias meter as well as with our, I believe the B&K Dyna Quick is what we call a transconductance tube tester. Someone maybe has better information on that. It's been a while since I looked up what that thing's actually doing, but it seems to be working pretty well. So let me know if you want to see more tube tests or if you want to see anything else related to this. But this is a quick fix, so we'll be able to get some new tubes in there for the customer and get him on his way. Thanks for watching.